Okay, so good day everyone. So this is ENS161 Statics of Rigid Bodies, Module 3 Analysis of Structures. So welcome to the third module of this course. So for this lesson, we will be dealing with the equilibrium structures made of several connected parts. So if you still remember, so the problems considered in the previous module is concerned about the equilibrium of a single rigid body, and all forces involved were external to the rigid bodies. So sa previous module natin, we have discussed equilibrium but only involving external forces. But for this module, or the problems for this module call for the determination not only of the external forces acting on the structure but also the forces which holds together the various parts of the structure or the internal forces. So, yun magiging discussions natin sa module na to. So, not only yung mga external but also yung mga internal forces na involved in holding yung structure into its rigid na state. So by the end of this module, you should be able to first define what is a truss or a frame, understand the moment of a force, identify internal forces in a connected structure, and analyze this, a truss or frame structure na problems. Okay, so consider, for example, so this crane, which carries a load W. So the crane consists of three beams, which is members, which is this AD, CF, and BE. So which is connected by frictionless pins. So these are pins that are frictionless, and also here. And it is supported by a pin at A and a cable DG. So this is a pin. So this is called the support. So it holds the frame into its static state. So this is a pin or a hinge and cable DG. Ito yung cable. So the free body diagram of a crane is drawn like this. So compared to the previous module, so we are only considering a one particle. So but sa analysis of structure, we will analyze the structure as a whole. So kaya mayroon siyang additional na mga forces or sa reaction niya. So dito sa part na to. So the external forces which are shown in the diagram include the weight. So this weight, so meron siyang downward na force. Of course, because it is a weight. And the two components, AX and AY, of the reaction at A. So, depending on the reaction, depending on the support, there could be 2, 1, or 3 reactions. So, mamaya, i-discuss natin yung mga supports used and yung corresponding na mga forces na, or reaction na acting doon sa support na yon. So, in this case, sa pin or sa hinge, meron tayong dalawang reactions, that is AX and AY. And the force T exerted by the cable D. So, yung force T na to. So, sa previous module natin, we have discussed na, or we have learned that cables are cannot carry compression loads but strong in tension or tensile load. So it is assumed, or it is a given, that when cable is presented to its force, it is always in tension. So the internal forces holding the various parts, so we have mentioned na i-discuss natin yung, or hahanapin natin yung mga internal forces. So the internal forces holding the various parts of the crane together do not appear in the diagram. So in the free body diagram, we cannot see the internal forces like the forces na nandito sa mga pin na to. So, hindi natin makita sa free body diagram. If, however, the crane is dismembered, and if a free body diagram is drawn for each of its components or parts, the forces holding the three beams together will also be represented, since these forces are external forces from the point of view of each component part. So, if we dismember itong crane natin, so makita natin yung mga involved na mga internal forces holding the structure together on the pins na to sa C, P, and E. So, every member gagawa natin ng free body diagram. So, it will be noted so that the force exerted at B, so for example dito, so ito yung corresponding na or yung connection niya dito, here and dito. So, there is a force. So, this assume na merong compressive force, and also meron ding opposite force dito, same magnitude, same direction, but with opposite sense. So, that is the this is in conformity with the Newton's third law, which states that the forces of action and reaction between bodies in contact have the same magnitude, same line of action, and opposite sense. So, for example, here yung connection B. So, dismember natin yung connection B. Meron tayong compressive force, for example, sa on this part ng B, and dun naman sa isang member na B din is meron ding compressive force. That is with same magnitude, same line of action, but opposite in direction or opposite sense. So that goes the same for the C and E also. So may E tayo, merong compressive force. Dito naman merong opposite sense na compressive force. So sa C naman, meron tayong, so this is opposite dito, and this force is also opposite dito. Okay, so the Newton's third law must always be applied. So hindi pwede na dito lang yung may force pero dito walang force. So kasi for the body to be in a equilibrium state or a rigid body, kailangan parang if i-combine mo sila, nagka-cancel out yung mga forces. So if you combine C here, so magka-cancel out yung force na to dito dito. So it holds the principle of the equilibrium. Okay? Okay, so what is a trust? So we have mentioned kanina sa overview or sa dun sa previous slides na analysis of structures, then the structures refers to a truss or a frame. So the truss is one of the major types of engineering structures. So truss provides both a practical and economical solution to many engineering situations. So that is, for example, for bridges and buildings. So if you have seen mga construction sa bridge, so truss are yung mga yung mga triangular na mga connected na mga beams or mga steel members. So a truss consists of a straight members connected at a so each member can then be treated as two force member, and the entire truss can be considered as a group of pins and two force members. So take for example the figure here. So this is a example of a truss na structure. So meron siyang support dito, meron dalawang support, and force P applied at D. So truss members are connected at their extremities only. So thus no member is continuous through a joint. So meaning there is in selecting members or identifying the members of a truss, it is on the between the connections or between the pins lang. So we have member AC, AD, CD, and DB and CB. So there is no member AB. So kasi meron tayong connection dito. So hanggang extremities lang yung considered na member. So that is AD and DB. So wala tayong tinatawag na member na AB. So um, the most actual structures are made of several trusses joined together to form a space framework. So each truss is designed to carry these loads which act in its plane and thus may be treated as two-dimensional structures. So in general, so the members of a structure of a truss are slender and can support little lateral loads, so or different loads. So therefore, loads must be applied to the various joints. So meaning loads can only be applied sa joints. In case of a truss, loads can be applied only sa joints niya. So this is on A, C, D, and B. Um, and not to the members themselves. So for example, hindi ka pwede mag-apply ng load doon sa members like dito. So hindi ka pwede mag-apply ng load dyan, ganyan. Sa in case of trust kasi trust members or yung mga materials na ginamit ng trust are slender and can support little only maliit lang na lateral loads like mga wind load. So but if you apply a concentrated load or distributed loads sa member mismo, so hindi kaya ng truss yon. So that is in the case of a frame. So sa frame naman, you can apply loads on its members mismo. So but sa truss natin, you can only apply loads dito sa mga joints niya. So it is C, D, and B. So for example, here nag-apply tayo ng load dito sa D, which is load P. So in terms of weight naman, so we have learned that for every body na merong weight, the weight is subjected dun sa center niya or sa center nung body na yon. So doon yung weight ng structure. But in case of a truss, so we can say na yung weight niya is dito. But hindi. So the assumption on truss, so the weight of the members of the truss are also assumed to be applied on the joints. So for example, yung weight of member AC, yung weight niya is yung kalahati nung member AC. So for itong weight na to, yung part na to, yung weight niya is applied dito sa joint na to and yung kalahati naman is applied sa joint C. So half of the weight of each member being applied to each of the two joints the member connects. So although the members are actually joined together by means of welded, bolted, or riveted connections, so you can search on that. So these connections could be welded, bolted, or riveted. Itong connection na to. So it is customary, so for simplicity or for convenience in solving and doing analysis of structure, it is customary to assume that the members are pinned together. So therefore, the forces acting on each end of a member are reduced to a single force. So that's why kung meron tayong member, so for example this member, so meron lang single force na present dun sa structure na yan. Okay? So therefore, the only forces assumed to be applied on a truss member are a single force at each end of the member. So therefore, we can say that each member can then be treated as a two-force member and the entire truss can be considered as a group of pins and two-force members. So for example, yung imbis na kung nakita kayo ng bridge, so pag titingin yung connection, merong maraming bolts or rivets. But for sa analysis of structure, it is customary to assume that it is a pin connections. Parang isang connection lang sila. So para maging group of pins and two-force members yung structure natin. So in analysis of trust, a member, an individual member can be acted upon by two forces. So First is could be in tension. So a member, so as if you can remember yung previous slides natin, iba-iba yung forces applied in each member. So this, for example, is in tension, and also it could be in compression. So depending on the structure or yung magiging solutions natin. So this is the second sketch of a member. So for member 1, it tends to stretch or parang hinihila niya yung member. So sa member 2 naman, which is in compression, is kino-compress niya yung member na yun. So sa truss, members can only be subjected to tensile or compressive na forces. So example for this, maybe this member is in tension, or this member is in compression, tension, in compression. So depende sa magiging solution na magiging problem natin. But in solving truss problem, madali lang ma-determine kung compression or tension ba yung force member, which i-assume natin siya. So, gaya sa previous na sample natin sa previous module, so, I-assume natin that the force is in tension or in compression. So, kung magiging positive yung result, meaning tama yung assumption. Kung negative naman, meaning opposite yung assumption natin. So, i-change natin yung direction or yung sense ng force and yung sign niya. Okay? Okay, so there are different types of trusses. So, meron tayong typical roof trusses, meron tayong bridge trusses, and other types of trusses. So, roof trusses are Pratt, Hoe, and Fink. So yung pinaka-common na nakikita natin ng mga roof truss, if nakikita nyo ng mga construction sa mga roof trusses, are these Hoe. So, and also yung Pratt. So, for me, personally, hindi pa nakita ng truss na kagaya nitong flink truss na to. So, yung common lang nakikita natin sa mga roof trusses sa mga residential houses is yung Hoe and yung Pratt. So, sa bridge truss naman, so merong Pratt, Hoe, Warren, Baltimore, and K truss. So, usually din kung titingnan natin yung mga bridges, for example, dun sa yung sa Pawak, yung palabas ka ng Marawi. So I think those trusts are nandito lang, nasa tatlo, no? So Pratt, Hoe, and Warren. So but Baltimore, so medyo complicated na yung structure ng trusses niya, no? Other types of trusses are stadium. So these are example of a stadium truss. Cantilever portion of truss. Cantilever are yung mga naka-overhang, for example, na truss. And bascule. So hindi po nakita ng ano ba yung structure na may ganitong type of truss. So maybe you can search on that. So as you can see, iba-iba yung mga support. So meaning support is yung structure or a connection that connects the member or yung structure dun sa soil natin, or for example yung sa land sa base. So merong ganitong type ng support, ganitong type, so as you can see para siyang may may mga roller. So and also ganito. So parang nakapatong lang siya. So i-discuss din natin 'yun. So here are different support or connection that with its corresponding reactions. So reactions, support, and connection. So first support or connection is roller, rocker, or frictionless surface. So ganito yung sa yung sa bascule, ganito yung connection niya. It could be a frictionless or with friction na surface. So so for example, yung kanina meron tayong roller, ganito, and a rocker. So the reaction for that is force with known line of action. So isa lang siya, no? So one unknown force yung pag roller yung nakita nyo na sa support or connection. So pag titingnan mo yung internal force or yung external force na nandun, isa lang yung force na i-apply natin. So this is only for ito lang, pataas lang. Why? Because rollers are moving this sideways, so no, so left or right, so but it cannot move downward or hindi na upward, no, kasi anong sense, so mawala na siya, so it cannot move downward, so meaning the force holding the roller are force na ganito, so upward. So ito yung reaction niya pag roller yung ginamit. So pag ginamit naman is pin or hinge, as I was saying kanina, or rough surface, meron tayong the actual reaction is ganito yung reaction niya. So isang force but at an angle. So but for simplicity, or so gagawin nating dalawa para XY lang yung involved ng mga axis, no? So merong dalawang force that is on the x-axis and the y-axis. So ganito yung ano niya, ha. So dapat toward. So for example, roller dapat upward. Yung hinge naman is dapat in compression or compression. So parang compression siya, no? In compression doon sa member. So meron tayong dalawang unknowns. So sa fixed support naman, so fixed siya, parang naka-embed siya sa ground. So meron tayong force and a couple, meaning merong force and a moment. So mamaya discuss natin ano yung moment. So but for simplicity, meron tayong tatlong forces, that is on x-axis, y-axis, and moment. So moment are parang rotating force. So if you apply force here, so meron siyang moment kasi baliktad. So if you apply force here, so meron siyang opposing moment dito, no? So in-oppose na yung force, parang rotating. So mamaya discuss natin, so also is ma-arte kung ano yung moment. Okay, so moment of a force about a point. So what is a moment? So moment, or the magnitude of moment O, measures the tendency of the force to make the rigid body rotate. So ito yung pinaka-keyword natin, rotate about a fixed axis along MO. So take for example a body here. So moment at point O here. So say so you have a point O. Moment at point O is the product of the force applied here multiplied by the distance d from O. So this distance should be a perpendicular distance with respect to the direction of F. So it should always be perpendicular, okay? So kailangan yung d natin is perpendicular to the force F going to point O. So that is the moment. So moment, so meron tayong sign convention, no? So if the moment is going counterclockwise, so if this is a clock, so this is counterclockwise, so meaning positive yung moment natin. So it could be negative din, but then sa clockwise is positive, but for para uniform tayo or similar tayo sa reference natin, so we will take counterclockwise moment as positive and clockwise moment as negative. Okay? So yun yung magiging convention natin sa mga discussions sa problems natin. So okay, so another body subjected by force at this direction with a perpendicular distance d from O. So the moment is clockwise, no? So this is a clockwise moment, meaning negative. So that is force. So yung magnitude ng force multiplied by the distance d. So, okay, so remember, always perpendicular yung distance d natin with respect sa direction ng F natin. So one good example of moment is ito. So example, we have a wrench and a bolt and nut. So so the guy here is applying force. So say dito sa end na lang or dito. Okay. So applying force here, downward na force. So this is force F, and the moment created is at this point. So ito yung naro-rotate na part ng sa diagram na to, no? So the created moment is clockwise na moment. So the distance, ito yung magiging distance niya. So the perpendicular distance d. So ganyan. So yung moment natin created due to the force applied by this hand to the wrench. So then at this point O, so yung nagka-create siya ng moment na F d or force times distance. So the longer the d, so the larger the value of d, the greater the moment. And also, if you have tried using wrench, so the further you are away from the nut or yung tatanggalin mong nut is mas madali siyang ma-rotate if mahaba yung malaki yung distance d, no? So the closer you are, mas mahirap siyang i-rotate. So this is an example of a moment. So I hope naintindihan nyo, no? So okay. So yan yung moment of a force about a point. Okay, so there are two methods in the analysis of a truss. So first is by method of joints. So the method of joints is most effective when the forces in all the members of a truss are to be determined. So method of joints is used or used in solutions where you are going to find all the forces subject to each member of the truss. So say you have a truss here applied with force P at joint D. So first you will find the reaction. So this is a hinge or a pin here and a rocker or a roller. So a rocker or a roller, meron tayong isang reaction that is upward. So let's say RB, so reaction at B, and RA, reaction at A. So say this is RAX and this is RAY. Okay? So ito yung maging reaction niya and force P. So these are the external forces. Now for the internal forces, so we will dismember the truss, and so makita natin na so each member is subjected to tension, or this is compression, this is tension, tension, compression, and tension. So each member is subjected to tensile or compressive forces. So at each joint, makikita natin kung ano yung mga involved na mga forces. So sa method of joints, titingnan natin kung each joint, so say joint A, isa-solve natin yung unknown na mga forces. So say this is member AC, so this is TAC, and this is CAC pala, compression, or say F na lang, F, force F, okay, so this is force AC, and this is force AD. Okay, so as we are discussing kanina, so this is force AC, so this is also force AC but with opposite sense, no? So ito yung force AC is the force subjected to member AC. So ganun din sa ibang mga member. So yun yung method of joints. So we will move from starting from first joint to every joint to find the mga unknown forces na lang sa mahanap natin lahat ng forces. So there are steps in solving analyzing trusses using method of joints. So your solution will consist of the following steps. First is, so pinaka first, since first discussion natin, is draw a free body diagram of the entire truss and use this diagram to determine the reaction at the support. So, yung figure kanina, say for a simple truss, ganito, and force applied here. This is hinge and this is a roller. So, meron siyang reaction na ganito, no? Ganyan. So, given force P, so, isa-solve natin yung reactions muna. So, reactions using the free body diagram. So, pag na-solve natin yung reaction, we will locate a connecting joint only two members. So, in finding joints, you will locate connecting only two members, no? So, two members lang. Sa first na mga, sa first solutions mo, you will choose muna yung two members kasi mas madalis yung masolve kasi less lang yung unknown. So, and you will draw the free body diagram of its pin or its joint. So, for example, yung joint dito, so this is A. So, joint A. So, meron tayong RAX, RAY. So, meron siyang value. Meron tayong value dito, no? So, this is A, B, and C. So, dito na joint naman. So, meron tayong, say for example, sa force, AB. Say, assume natin na compression siya. And force, AC, assume natin na intention siya. So, ito yung dalawang unknown. So, since we have the equation of equilibrium, which is summation of forces along x is equals to 0, and summation of forces along y is equals to 0, and summation of moment is equals to 0. So, but in joint method, we usually use itong dalawang equation lang. So, we have only two equations na gagamitin. So, meaning, we must also have two unknowns lang din when solving the problem. So, that is why yung first steps is only choose two members kasi para dalawa lang din yung unknowns natin. So, two equations, two unknowns. So, solvable yung magiging equation natin. So, you will apply the equilibrium equation, summation of forces along y and x equals to 0. So, yung mga previous natin na modules, i-apply natin yun, no? So, for members like these members, so, ano natin yung components niya into x and y. So, masolve natin yung forces using or applying these equations. Now, third is to locate a joint where the forces in only two of the connected members are still unknown. So, next is simple truss lang to, no? So mamaya ma-discuss sa isang example. So, maintain natin yung mga kung ano yung isi-select natin na joint na solvable yung agad yung mga unknowns. Then repeat this procedure until the forces in all the members of the truss have been found. So note that the choice of the first joint is not unique. So not unique kasi you know na hindi ka magse-select ng kahit saang joint. So magsisimula ka doon sa joint na madaling ma-identify. For example, dito sa joint A. So it is obvious na mag-start ka dito kasi meron ka ng values ng reaction. So yung unknowns na lang is yung dito. So it is not ideal to start here kasi isa lang yung given mo na equation but dalawa yung unknowns mo. So hindi mo masasolve yung problem. So but anyway, so sa next na sa sample natin malalaman na mas maintindihan hopefully yung magiging on how you solve or analyze a truss using joint method. Okay, so next method of analyzing a truss is by method of sections. Now, method of sections is used if the force in only one member or the forces in a very few members are desired. So, meaning, sa trusses na yon, you only need to find few members like tatlo, isa, dalawa, in a specific section. So, and another method for that is yung method of sections. So, it is more efficient to use method of sections in finding mga desired or yung specific na part ng trust member yung ihahanapin natin yung mga forces. So, for example, especially sa middle, so hindi ka na mag-join papapuntang middle but diretso na dun sa middle yung method of section. So, say for example, we have a truss here supported by a hinge at G and a roller at E. So, you need to find the force at the members BD, BE, and CE. So in that case, you will cut the truss in this section. So we'll cut it here. So pag na-cut mo dyan, meron kang, it's either you choose yung left na section or yung right na section. So but first, of course, you will need to find yung mga reactions muna before you cut any section. So first step is free body diagram. You find the reactions and then you will find the force member na hinahanap natin. So cutting the section at N here. So you will have the forces FBD, FBE, and FCE. So usually, when using method of sections, so ang first assumption natin for every forces na nakat or member na nakat, the forces there are in tension or in compression or yes, in compression. So yan yung magiging assumptions. So and this is the E section. So yan. So ito yung gagamitin na diagram or drawing in finding the forces FBD, FB, and FCE using yung mga equilibrium equations natin. Summation of forces x equals to 0, summation of forces y equals to 0, and summation of moment equals 0. So using these equations, mahanap natin yung mga hinahanap na bar forces. Okay, so this is a given and given. So you can also, for example, if you cut this section here, you can also have yung section dito. So ganyan. So this is FCE, FBE, and FBD. So you can also use yung itong side na to ng force trusses. So you have the reaction E here, Y, and reaction EX, and reaction G. So yeah, so using this member, so mahanap mo yung mga unknowns natin. So depende sa preference niyo. So there are problems na mas madali sa isang section compared dun sa natirang section. So for example, mas madali siguro yung section na to compared sa section na yung sa right na section, no? Kasi konti lang involved na mga forces. Okay, so in solving or analyzing a truss with method of sections, your solution will consist of the following steps. So first, of course, so very basic, or yung pinakauna talaga na gagawin is draw a free body diagram. So ito yung pinakauna na dapat na ginagawa. Draw a free body diagram. So of the entire truss, and use the diagram to determine the reactions at the supports. So when drawing the free body diagram, tatanggalin na din yung mga support, and if i-substitute mo yung mga reactions niya, yung mga forces na nandun sa support, and then you will find that reactions using the equations natin. And after finding the reactions, you will now pass a section through a three member of the truss. So yung kanina, yung ikakat mo yung section through three member of the truss, one of which is desired, or yung tatlo yung desired mismo. Now select, after that, so you will select one of the two portions of the truss you have obtained and draw its free body diagram. So it's either you choose yung left na portion. So simple nag-cut ka, so you'll choose the left na portion or yung right na portion. So and after that, you will draw the free body diagram as you have as what you have seen kanina. So mayroong free body diagram. And then you can now write the three equilibrium equations. So that is yung summation of forces x, summation of forces y, summation of moment is equals to 0. And then an alternative approach is to write a single equation. So there are times na for example yung kanina no, ano ba yun yung parang yung figure ng ganito. So ito yung mga forces niya no. So merong P and P force dito. So for example, if ito lang yung kailangan mo na force, ito lang. So you can write a single equation, meaning you will use a point or a joint where you can make an equation na may eliminate yung ibang unknowns. For example, this is continuous to point E kanina, diba? So if you set your equation here, so pag mag-moment ka dito, the effect of force, this force and this force will be 0. Why? Because it is passing through the point mismo. So meaning yung force times distance, where yung distance is naging 0 na siya kasi it is passing through the point. So meaning yung moment, yung effect ng force na to and force na to with respect to the point E is magiging 0 na siya. So meaning ang matitira lang na unknown mo is yung force na to. So meron siyang distance force na D. So meaning itong tatlo lang yung nasa equation. So mahanap mo yung force na to. So yan yung alternative approach to write a single equation. And next is keep in mind that the section you use must intersect 3 members only. So since you only have three equations, so summation of forces x equals 0, summation of forces y equals 0, summation of moment equals 0. So dapat yung maximum unknown din natin should be tatlo lang din. So meaning if you have a truss, so for example, you have this truss, no? Ganyan. So pwede ka mag-cut dito, but not dito, no? So hindi pwede kasi marami masyadong makakat na mga section and hindi mo na masasolve yung equation kasi more than 3 na yung unknown mo. So it should be 3 equation and 3 unknowns. So yun. Okay, so we'll have examples later. Okay, so that's it for our lecture. So we will have a separate video to be uploaded sa YouTube channel natin, in this YouTube channel, kasi medyo mahaba-haba na yung lecture. So we had 40 minutes for the discussion of the theories or yung how you solve yung mga or how you analyze a trust. So we will have separate video for the sample problems. Okay, so that ends our module 3, and thank you for listening and have a good day.